Hello everyone, in this video we'll be solving problem 15, 3 sum. The problem statement is we are given an integer array nums. We need to return all triplets whose sum is equal to 0. Another caveat is the solution must not contain duplicate triplets. In example number 1, with the given input, there are a total of 2 unique triplets whose sum is equals to 0. Although the problem statement seems easy and straightforward, coming up with an optimized solution is the challenge here. So now let's switch to whiteboard and discuss a couple of approaches, starting with the brute force, following up with a better and optimized solution. The simplest solution to solve this problem is using brute force, where we'll run 3 nested iterations to capture each number, add the values with each other to see if the total adds up to 0. If we encounter any such triplet whose sum is equals to 0, we'll save it in a collection which will be returned as an output at the end. We continue this iteration until we have gone through all the possible combinations. With this solution, our time complexity is going to be exponentially high, which is O of n cubed, because we are running 3 nested iterations, while the space complexity is O of n, as we are maintaining this collection with all possible combinations. Although this approach solves the problem, our time complexity is very high. So now let's think about how we can optimize our solution. One optimized way to solve this problem is using 2 pointers. But before we start discussing the 2 pointers approach, we need to make sure that the input array is sorted. As the name suggests, 2 pointers requires the use of 2 pointers left and right, where left points at the first element in the array while the right points at the last element. We can then add the 2 values that the 2 pointers are pointing and compare it against the target, what we are expecting. Depending on the sum of the 2 values and comparing it against the target, we determine what update should we make to the pointers. There are 3 possible cases that could happen. Sum is equals to target, which means the value is what we are expecting, so we don't need to update either of the 2 pointers or decrement the value. Another scenario is where the sum is greater than the target. So if we want to make sure that the sum is equals to the target, we need to reduce the sum, which implies that we need to reduce the sum, and the only way to do that is by changing the right pointer's value. Because it is pointing at the rightmost element in the sorted array, its value will be higher. So decrementing the pointer will help us point to the next value, which could be smaller, giving us a lower result. And the last but not the least scenario is sum is less than the target. So to bring the total closer to the target, we need to use a bigger number. As right is already pointing at the rightmost or the bigger number, we need to change the value of the left pointer as it is pointing at the smaller number. So if we increment its value, it will move on to the next number, which could be higher than the current value. Using this approach, we can effectively figure out all possible combinations in the array whose sum is equal to the target, while keeping our time complexity of O of n. Because we need a total of 3 numbers to build our combination, we'll have to modify this 2 pointers approach. One simple improvement that we can do is to run a for loop that will help us point or get the third number that we need to build the triplets. All we need to do is structure the code in such a way where the outer loop is actually the for loop, which will help us get the first number, and inside it we'll run a while counter using the 2 pointers approach, which will give us the second and the third number. Once we have all 3 values in the innermost loop, we can add them and then compare the value with the target 0. If the value matches, we can save all the 3 numbers in a collection, which will be returned at the end. The only thing we need to be careful about with this approach is to make sure none of the 2 pointers are pointing at the same index for a given calculation. We don't want to use the same values or duplicate values to build the collection. So as long as we can make sure that the indexes are different, This approach should help us solve the problem efficiently. Let's do a couple of simulations to understand how will this work. Starting with sorting the array. The sorted array would look something like this. Starting with I is equal to 0, left is also going to be pointing to the first number 0 and right will be the last character in the array. As I and left pointer are pointing at the same index, we can't continue forward, so we'll just increment the left pointer by 1. So I is pointing at this number, my left is pointing at -1, while right is pointing at 2. These three numbers give me the total sum of -1. As it is less than the target, we need to increment our left pointer by 1. So for the next run, my I will stay as is, left will be incremented to 2, right will stay as is. The new numbers are -2, 0 and 2, giving me the sum of 0, which is what we are expecting. So we'll record these values inside the collection and continue with identifying more combinations. With this solution, our time complexity is improved to O of n square, as we are running one for loop for this outer one and the other one is the nested two pointers approach. And the space complexity is still O of n, as we are maintaining this output with all the combinations. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is my C# solution. I start by initializing my return value variable, which is a list of list. Following that, I am sorting the input array. After that, I start a for loop to point to the first number. In an effort to improve my solution, I am checking if the current number is equal to the previous number. Because I want to make sure that all combinations are unique, this check makes sure that we are not duplicating or running through the same cycle again. After that, I'm starting the two pointers approach where I'm initializing my left and the right pointer, starting a while loop. Inside the while loop, I'm adding all the three numbers that I, left and right pointers are pointing at. If the sum is greater than 0, I'm decrementing my right pointer. If it is less than 0, it means I need to increment my left pointer to get a higher sum. If either of the conditions are not met, it means that the sum is equal to target, that is 0. So I am creating a new collection and adding it to the return value variable. After which I am incrementing my left pointer so that I can figure out more combinations. This is one more improvisation that we are doing to avoid running into duplicate iterations and making sure the combinations are unique. After the for loop is complete, I am returning this return value variable as our output. This code, when submitted on LeetCode, beats nearly 25% of the submissions in terms of runtime and nearly 40% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.